Hey everybody, welcome back. Miss Lakin here at the Putnam. I am in the Putnam's Weather Gallery. Today's topic is all about weather. So today I'll walk you through your activities. Chris, one of our curators, is going to give you a peek at one of our cool things in our collection. And you're going to get to see some of our interactives in this space right today. So let's get started. So what is weather? Weather is changes from day to day in our atmosphere. So depending on where you live, it may be different from other areas. So the study of weather is called meteorology, and the people who predict it and study it are called meteorologists. And over time, changes in the weather, so many years apart, we call that climate, is that change in our weather. And people that study that are called climatologists. So many things when it comes to weather. Weather affects us every single day, from what we wear, what we do, activities day to day. Even it affects the crops that we grow, buildings, structures that we build, even how we get from place to place. So many things are affected by the weather. It even affects how we feel day to day. So the cool thing about weather is that we can study it and we can predict it. And in this area, we can have extreme weather. We can have really nice sunny days, or we can have really high dangerous winds. So things as blizzards, tornadoes, even the derecho that we had in August in 2020. It's crazy how it can impact our landscape, and it impacts just our day to day. So we're going to talk a little bit more about weather today. We'll talk about wind and how it affects landscape. We'll also experiment with how wind flows with our tornado or our air fountain tube in our gallery space. But I want to first off by talking about seasons, because we do have different seasons in our area. So it does have to do with where our planet is at in space. So I'm going to show you a little demonstration on seasons. And I'm going to use this with my sun I have here and our planet Earth. And we know that planet Earth orbits or circles around the sun. All the planets in our solar system do that. And our planet Earth does also rotate. So it rotates, and it takes 24 hours to go the full rotation around. And that's how we have our day and night. But for our seasons, our Earth is actually tilted. So this is just a black straw, but this is our planet's axis. So this is the up and down line, imaginary line on our planet. And it actually looks like this. So when our planet is like this, one part, so the southern hemisphere right now is closer to our sun. So when that happens, we have summer, and then the northern hemisphere, it would be winter because it's not as close to our sun here. So as it's going around, it's orbiting around, it stays in the same tilt, so it doesn't change its tilt. So now look, now the northern hemisphere is closest to the sun, and that's when we have summer. So just by the tilt of our planet, that's how we can get the different seasons and our whole year, which is really cool. The spin of the Earth also causes an effect called the Coriolis Effect, and that's how our winds are created. So our planet, we have, and the equator is in the middle, so that's the hottest area, and our north and our south poles, those are really cold. And because of the pressure difference, so cold air, it's really heavy, and hot air is really light, and so hot air rises, and when the movement of air is happening and the pressure difference change, it creates winds, so the movement of air. And it can be extreme, or it can just be not super extreme. So we are going to experiment with wind. This is our air fountain, and we're going to do a little prediction, just like we are predicting what the weather will be like. So scientists can track weather and wind across our globe, and we're going to do a little prediction on where our scarves are going to blow through our fountain, or air fountain here today. So this is our air fountain. And I have some scarves in the tubes here, and I want you to predict. So where do you think this scarf will blow to? So you ready? So let's test it out. Here we go. Hey everybody, we're gonna do our weather activity. So go ahead and grab your learning kit. I'm gonna pull out the weather kit for all our activity supplies. And go ahead and pull out your activity card and booklet. And the first one, or the one that we're gonna do right now is up, up, and away. And this is gonna be really cool. It's gonna be a paper kite. For your kite, go ahead and you're gonna need your piece of cardstock paper. So go ahead and grab that out of your bag. You'll also need your a straw. So you need straw and our kite string. We're gonna need that. And the 2 streamers you also have in your bag. Okay, so let's get started. For your kite, go ahead and take your paper and you're gonna fold it hamburger style. So go ahead and if you're doing this at home, you can follow along. If you're gonna do it later, just watch and listen and you can do it later. Okay, go ahead and open up your paper. And now we're gonna do a little measuring. So you're gonna need your ruler, so go ahead and grab a ruler. On one side of your paper, from the crease, go ahead and measure 1.5 inches on each side. And you're gonna measure 1.5 inches for a couple different markings. So I'm gonna recommend go ahead and find 1.5 and mark it on your ruler. And then I'm gonna go right from the crease, I'm gonna measure over, I'm gonna make a mark. And then on this side, I'm gonna measure over and make a mark. Okay, so I did 1.5 inches from the crease on both sides on this side. We're gonna go to the other side and we're gonna measure 3 inches from the crease. So go ahead and find 3 inches, 1, 2, 3, and do it on both sides. 1, 2, 3. Okay. So we have our markings. So the next step, we're gonna draw a line from our markings on each side. So you can use your ruler. I found that it's a little short, so you can use your activity card if you want. So go ahead and mark up, or find your mark on each side, and you're gonna draw a line from point to point. And you're gonna do it so both sides will look the same. Okay, so it should look like this. So this is what yours should look like. You'll have 2 lines from on both sides. Then go ahead and you are going to crease at that line. So go ahead, you can fold your paper in half again, and then you're gonna fold away from the crease. So I'll demonstrate how your fold will look. So there's one side, and then I'm gonna do the same thing to this side. So I'm just gonna flip it over. And this is what your kite should look like so far. So it's looking pretty good. The next step we're gonna do is go ahead and grab your streamers, and we're actually gonna attach these to the bottom of our kite, or the back of our kite. And you're gonna do that on the wider part. So the bigger side where you did the 3 inches. And I'm gonna take my kite, or my streamers, I'm gonna kind of put them together. And if you have tape at home, I would recommend using tape for this activity. However, glue works just fine, so I'll demonstrate with glue too. And you have that in your kit, so you have it with you. Okay, so I'm gonna put some glue right here inside where I'm gonna attach my streamer. I'm gonna do it on the end, inside the crease. And I'm gonna actually apply some more on this side. And we're gonna actually glue these sides together. So go ahead and apply some more glue in there. And you're gonna push it together so you attach both sides. And so your streamers will be coming out of the bottom of your kite so they can fly in the wind. And you can definitely, you'll be able to see the direction that the wind's blowing to, so that'll be kind of a helpful tool when you're experimenting with how it flies. Okay, so once you have your kite like this is a good time if you want to decorate your kite. Be mindful that when you're flying it, you'll be seeing this side of it. So if you want to decorate, you can decorate the top and the bottom. I'm going to draw a sun. How about a sun? So be creative. Everybody's kite's going to look different. You can do different patterns, different shapes. I did a couple on mine. Also, maybe I'll do some on the bottom too. Maybe I'll do some zigzag lines. Okay, so I have a little design on the back and the front. And we have our streamers coming out, so we'll be able to see the wind. Okay, so after we have our design on there, or your design on there, we're gonna do the top part, or the next step to your kite. So the next step we're gonna do, so go ahead and hold your kite upright, and you're gonna find the widest part. So that's gonna be the two corners of your paper. And from the corner, we're gonna do it together. I'm gonna measure 1.5 inches down from each corner here. And then this will help our kite with the shape so it can fly through the air really, really well. So let me measure out 1.5 inches. And then from my mark, I'm gonna make a line from this point all the way to the top. And from this point all the way to the top. And once you have your line, you're gonna make a crease. So you're gonna fold that paper so there's a crease. So let me do mine here and then I'll demonstrate. I'm gonna fold my paper just back and then I can see where the line is. Okay, that's where my crease is on that side. I'll do it over here. Okay, this is looking good. We have both sides creased, and we're gonna add a little bit of support in the middle. So the next step, you're gonna need your straw. So go ahead and grab your straw, and we're gonna put our straw right to the point where we had just made those markings and creased it, so it'll look just like this. So go ahead and you can apply that straw on there. I'm just gonna put a little bit of glue to start off, and then I might put some more if we need it. And just lay that right there. And to help your kite be supported in the middle, we're gonna actually fold our markings and our crease up here, this corner of the paper down, so that it'll also be supported on the top like that. And we'll have a really great shape to fly through the air for our kite. If you are using glue today, you'll have to wait a little bit before you test it out. If you do use tape, if you have that at home, you can test it out right away. So, okay, so we have our support straw on there, and I'll press this down so the glue sticks a little bit. And the last thing that we need to do for our kite, we're missing the string. So for our string, we're gonna add a couple holes, and we're gonna lace our kite string through those holes. So you can do this a couple different ways. You can attach your string by your straw, so it has a little bit of more support there. Or you can add it underneath, kind of at the tip right here. So I'm gonna do mine to support my straw a little bit. So to do this, you're gonna poke 2 holes on, I'm gonna recommend you do this from the top so you can see your straw. So you're gonna poke a hole in the center on either one side of your crease, and you're gonna poke it through one side of your straw, whoops, and then the other side. Oh, my glue's not sticking. And just because I do have a little tape here, I'm gonna tape this down, that it'll be easier for you to see. Okay, and it'll be a little bit more secure. Okay, so we have our wings down. I have one hole poked on the top of my straw and then one on the other side. And then we're gonna take our string and we're gonna lace it through so we can tie it in the back. And if your string is hard to get through one of the holes that you created, a little tip, if you do have tape at home, you can put some tape on the end and just fold it over on the string and just cut off the extra, and then it's easier to thread through your hole. So go ahead, I'm gonna push it up from the back and pull it up, and then I'm gonna put it through the other hole that I created, and I'm gonna pull that down, and then I'm gonna flip it over, and I'm gonna tie a knot, and this will be our very secure kite string. I'm gonna do maybe double knot. Okay, so now we have our complete kite. We have our streamers attached, our string is secure, and we're ready to see how it works. Okay, we have our kite made. We are ready to test to see how it works. For your kite, you can go outside and you can experiment with outside if it's super windy. I attached a popsicle stick and rolled my string around so it was a little bit easier to handle. But if it's not windy outside, you can always use a fan. So that's what I'm gonna do today here in our Fab Lab, and we're gonna see how this kite flies. Okay, so let's check it out. Let me get my fan, my wind going. Here we go. Okay, pretty cool. So yeah, have fun experimenting with yours. You can definitely tell the direction of the wind by the streamers, so have fun. One extreme type of weather, especially here in the Midwest, is tornadoes, and that is with extreme winds. And tornadoes, they can get up to 300 miles per hour. So that is really fast. So we measure tornadoes by what's called the Enhanced Vegeta Scale, and it's basically a scale on wind speed and how much damage has occurred because of tornado. And the cool thing is we can study tornadoes so we can have better predictions and we can be safer when they are coming. So that's pretty cool about tornadoes. We know tornadoes start they create a vortex because hot air and cool air come and collide, and they start forming that twister motion, that vortex to create that tornado, the start of a tornado. Okay, this is our cloud machine, and this is really cool because we can create a cloud. Clouds help us predict weather just by how they look. So if you look up in the sky, cirrus clouds, those are the thin, wispy clouds. They're really, really high in our atmosphere. Cumulus clouds are those big, fluffy, cotton ball, kind of cotton candy looking clouds. And they can actually be kind of the troublemaker clouds. If they get really big, they can create thunderstorms. And then the low clouds, those are called stratus clouds, and they're kind of thin layers, and typically it looks a little overcast, the sun is hidden if those clouds are out. Plus, I bet you know the lowest form of a stratus cloud? Fog. So fog is the lowest form. So let's check out our cloud making machine here at the museum.
Hi everyone, this is Chris Chandler at the Putnam Museum. I'm the Curator of Natural Science here at the museum, and today I get to talk a little bit about lightning and evidence of lightning in the earth. Lightning is actually basically a stream of electrons, if you think about it. It's those negatively charged particles, and they're moving through the air. And air itself is a really poor conductor, so what happens is the air causes resistance as the electrons move through, and that causes heat because it's such a poor conductor. And it's just amazing the amount of heat that lightning can produce. You're talking something like 50,000 degrees Fahrenheit. That's like 5 times the surface temperature of the sun. That's crazy. Anyway, so what that does is when it hits something, it causes some interesting things. So like if it hits a tree, it literally will vaporize all the water in the tree, and that's why you get trees exploding when they're hit by lightning. The other thing it can do, and it's really kind of neat if you're a geologist, is that it can produce what's called a fulgurite. And fulgurites are basically what happens when lightning hits the ground, and sometimes what happens is it hits sand or something with a lot of silt and sand in it. It literally is hot enough that it melts the sand and turns it into a type of glass. So you're talking quartz sand. Quartz is what we make glass out of, and you create these wonderful cool tubes called fulgurites. And they're very interesting. I have a small sample of these, are actually from Muscatine Island, and they were collected in the 1930s, if you can imagine. And they actually represent evidence of a lightning strike. And the cool thing about it is a lot of times when you see one of these on the ground, it literally looks like, you know how lightning forks out? You'll see like the pattern of lightning that these make as it travels through the ground. So they're really cool, they're very fragile, so they're hard to find sometimes, but they're such a fun thing, and they actually prove that lightning hits the ground and you can see the evidence of it.
Okay, we are ready for our ions in action activity. So for this activity, very simple. You're just gonna need the balloon out of your kit. So take your balloon and you're gonna blow it up, and we're gonna tie it off, and we're gonna use this balloon to create static electricity, just like lightning in the sky. So lightning is a natural form of electricity, and it's caused by all the particles, the ice droplets, and all the things inside a cloud rubbing against each other. So that friction, that rubbing, is what's building up a charge. So we're gonna do that with our balloon. So go ahead, you can do this yourself, or you can ask an adult. So go ahead and blow up your balloon. Okay, that's good. Go ahead and tie it off. I usually use 2 fingers, wrap it around, and just push it right through the middle, and there we have our balloon. Okay, once we have your balloon ready to go, you're gonna rub it against your head. So rub it against your hair. So just like this, just rub it, and after maybe a couple rubs, maybe like 10 rubs, go ahead and see what happens to your hair. Oh my gosh. So like mine, I bet yours is sticking to the balloon. That's happening because you're rubbing, you're creating that charge with that friction, and we have a negatively charged balloon, and it's attracting my head, which is positively charged, so my hair is sticking all over. So go ahead and try it out. How does yours work out?